I'm CK. I was going to do something else tonight because I felt like I was getting in a rut with eurorack modules, but the kit I got from eBay didn't have any documentation and the URL included with it didn't resolve. So I've contacted the seller and we may come back to that one. So in the interim, I have more eurorack modules to assemble. I always will. And tonight we're going to take a look at this Frequency Central Static Leak kit, and this is their chorus, tap delay, and plate reverb unit, and I can always appreciate a good delay unit, so we'll see what it sounds like when we get it all together. Hope you enjoy it. So here's the bag. Frequency Central Stasis Leak full DIY kit, and build document URL, which does resolve. Even if it doesn't, it's got it typed out. I forget where I bought this from. You can find it, I'm sure. Let's just open the bag up first and take a look at the parts, see what we got, and then we'll dive in. Here's the mechanical bag, as it says. Here's, I'm not sure what that is. I'm going to assume it's one of the main DSP chips. And this is probably the other main DSP chip. And here are all the random electronic components, resistors, capacitors, a couple of LEDs and diodes, a couple more resistors. Here's the faceplate and the circuit boards. Get my 70-year-old razor blade, which I do promise to tell you the story of the 70-year-old razor blade sometime. But not tonight. Let's take a closer look at the boards to get an idea about the quality. I've done one other thing from Frequency Central. I did the Routemaster power supply, and I like that very much. In fact, I've ordered a couple more for another rack I'm building up. This looks real nice. The silk screening is really good, really clear. Frequency Central, Stasis Leak, designed by Rick Holt. The PCB is by Johnson Dunn. And here's where you drop in the Belton processing board, which again is in one of these bags. Let's look at the other board. Nothing new on the back. There's where the headers are going to go to connect the two boards together. Again, the boards, the silk screening is very good. I could put this together without the instructions because all the values are silk screened on. Very easy to understand. He's got a little quote here. We're going to be like three little Fonzies here. And what's Fonzie like? And there's no answer to the question about what's Fonzie's like. And we don't know if they mean Fonzie before or after he jumped the shark to create that famous phrase. Let's look at the front panel. And we've got time, density, so that's for delay, tone, wet, and it looks like a 3-position switch for chorus, delay, reverb, and looks like another switch will go here to set up the tap tempo for your delay. Then we've got time, control voltage, density control voltage, and synchronization. Then we've got signal input, and then a left and a right output, which is interesting. I don't know if this input is stereo or not. It's not typically stereo-ish, so we'll figure that out once we get it all put together. So, looks pretty straightforward. Get another small parts bin for the pieces we won't need for quite a while. Gave us a long strip of pin headers. And whenever you get a long strip of pin headers, that tells you primarily you're going to have to cut to the length you need, and you're going to have to be careful not to cut it too short because you'll run out of pin header. So be careful on your counting when you have to cut yourself, because you'll be sad if you run out of pin header and have to wait for something to come in the mail for you. Looks like, again, a pretty straightforward build. Looks like he's got quite a few notes here about what to do for various things. This is the Belton board, which comes all pre-SMD soldered. And again, they do a pretty good job at Frequency Central. Besides just saying install all the main components, they also have great pictures of how it will look when you're done. Again, now that every build guide is digital, fill them up with pictures, folks. Just make as many pictures as you possibly can. It will never hurt anything. So let's get started building this. We're going to grab out component PCBs. So we'll start with all our resistors. Resistors are always the most appropriate to start with. I wonder if I should have the clock in the corner there. We'll see. We'll see how that works out. Alright, so that's all the resistors and diodes on both boards, except for the LED, of course, the panel LED, which we'll get to later. I think I'm a little confused because there were 3 4148 diodes in the bag, and for the life of me, I can only find spaces for 2 diodes. There's no empty diode slots. The only slots that are left open are electrolytics and disc caps, and the trimmer ICs and power socket. And on the pots and knobs board, they're up. There it is. Ha! Gotta look. You gotta look really carefully sometimes. Now, one thing I noticed on this board, and it confused me momentarily. I'll go on the back. Let me see, we're getting a good shot there. There are a bunch of little holes all over the back of the board that also show up on the front, of course, and I'm not sure why they're there. I suspect that some of them are test points during development. Some things might be for future expansion, I just don't know. But what it did, it was a little confusing on some of the components. Like say, I'm sure you can't see this, but on this resistor, there's a hole right there as well as a hole right there. And someone might get confused as to, okay, I'm putting the resistor in there, but there's two holes close to each other. Which hole does this go into? So I might suggest that when they go final on this board, that they eliminate those. It makes sense when it's prototyping or development because, as I said, they may be test points. But when it gets in the customer's hands, you probably want to get rid of those to reduce potential confusion. Okay, what else do we have left? Oh yeah, we got to do the ICs. And as usual, for putting sockets on the board, get out my trusty locking tweezers and find a way to thread them through. And I'm going to get my Austin Ribbon Mike's solder buddy here. Again, I'll leave a link to this in the description. The solder buddy is a piece of silicone rubber with lots of holes and slots and so on, and it's very it's squishy, and also because it's silicone rubber, it doesn't burn. It's a very good, handy thing to keep things stabilized when you're soldering. And we'll put the trimmer in. And of course I didn't get that perpendicular at all. So let me straighten it up. There we go. Here we go. Now, normally you'd trim all that off, but the author says don't trim off the middle leg because we're going to be using that for calibration later. So we'll just trim off the outer ones. Then we're going to put some transistors on the board. Got two ICs there. And two transistors, but oh no, one transistor and one voltage regulator, I believe. And the other one goes here. Three male header strips, 11, 11, and 6. So we're going to take our header strip and cut it for 11 pins, 11 pins, and 6 pins. Now, if you were counting along at home, you realize that that's 28 connections between the circuitry board and the knobs and pots board and sockets board. That's a lot. That's more than in many other units. Doesn't mean anything. It doesn't mean anything good, bad, or indifferent. It just happens to be interesting that there are that many. Now on the pots and sockets PCB, now I'm not going to put the other row of sockets in right yet. First off, because he recommends you do them 3 at a time, but I also first want to see how this all lays out flat. Yeah, the components are pretty much okay. There's a gap on these pots between them and the panel, but that's not a problem, just something to point out. So I'm gonna Go back to the pan of ice. And hold everything. What? Why do you keep slopping around? Okay. I'm going to hold it in place like that, so everything is aligned while I'm soldering. Now, again, don't hesitate to use a bunch of solder on the jack leads, because they're going to get a bunch of mechanical activity throughout the lifetime of the unit as you pull audio jacks in and out of it every day, every hour. So don't go stingy on the solder. Let me do the last 3 sockets. Till last, I have a reason for that, because I'm actually going to put the switch in, put the switches in the front panel. And then solder them so I can get the, so I can make sure they're at the right depth. So I can make sure that the, and I'm not putting, you may notice I'm not putting the lock washers on these switches, because I am never going to take this unit on the road or in a rack that travels, so I don't care. I don't need the extra security of the lock washers. So first, on these, I'm going to put them in like so and see how I'm doing on distance to the hole. See here on this one, I've got the legs are not even meeting the circuit board underneath. Well, they should actually, if I actually get my act together here. Sorry, the camera's cut out. So as I was doing, I had a struggle getting them together, and the reason for that is the fit on the legs on this switch is really tight. You really have to press that in there. But with that pressed in, and then dropping this down, we adjust this nut to get the legs where I want them. In other words, the body of the switch as close to the circuit board as is practicable, while still leaving us a couple of threads above the panel nut for security. So I think that will be just perfect. And those components are done. So I'm going to take this back apart so I can put the header pins on. But I did forget something I just glanced over, and I forgot to put the power connector on. Just double checking the picture to make sure I have the orientation right. And the notch faces the caps, and there's a notch indicator on the board, and just for a final check, we check the notch. Notch goes in there, and the red stripe is by the stripe on the board indicating the negative 12 volt side. So now we gotta tack this. Okay, now the thing I dread most about this part of the project is cutting this part of the pin headers, because these pins, if you mess it up, you're just sad. And I want to get a good pair of cutters. Hold on a second. I'm going to use my carbide edged cutters here. I forget which company. Oh, this is Schmitz out of Germany. These cutters will cut through anything without damaging the jaws. So now again we've got to do 4 female header strips to the correct length, 13, 11, 11, and 6. We've already got a 6, so we don't need that. We need a 13, 11, 11, and 13, 11, 11, 11. I'm going to count these. Okay, so we've got like 4 or 5 pins slop with that count, so I'm okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I'm going to count that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So right at that point there. See, because what happens is you invariably burn a pin on the end where you just cut. So that's why you want extras at the end of the stack. Let's count again. And as you can see, I've got dead pins on the workbench here. So the 13, by the way, is the one that goes to the AccuBell card right there. Okay, there's all the pins soldered. Now we're going to get the LED. We're going to put the LED. We're going to get the LED. Put it through the hole. Then we're going to drop the front panel on. And screw some panel nuts down. So we've got the panel secure. Now we'll drop the LED through the front. That's the front panel nuts all put on. The knobs are density and time. I'm not a huge fan of these knobs. They're pretty cheap plastic. Doesn't really go with the rest of the quality of the unit. I wish they had gotten some upgraded knobs, but that's minor. That's my only complaint. Now I'm going to do the 2 chips. We've got a TL074CN. We've got two TL074 CNs, even though the board is marked TL084, and these are TL074s. And on the photo of the board, they've got 8.4s, but these are 7.4s. But we'll put them in because that's what was in the kit, and it either works or it doesn't. Oop, I've got the notch at the wrong end. And the other chip is in. And now the next step is the magic step of mating all these connectors, and we've got a lot of connectors to mate. And this one is a little okay. Let's drive those home. Yeah. So the camera's cut out on the last steps. So got it all together. Again, these three connectors, really, it's a little juggling act to get them all in quite right. Then the master brain of the operations slots into this other connector like that. So the unit is done, a nice build. Total time was 2 hours and 6 minutes of build time. And we're not going to turn it on tonight. I've got to go feed the cats. So we'll give this a test run tomorrow. Okay, for this afternoon's test, we're going to be running a Befaco ADSR Division 6 sequencer, ADX Systems VCO, Punching Panda Punch, a Patching Panda Punch VCA, and then of course the Stasis Leak. So bring it in tight on that. And we'll do a little chorus first. Say a third of the way up on density and time, about 2/3 of the way up on wet. Tone is in the middle, and we're in chorus. Let's fire off a couple of notes just to give it a try. So we can hear a little chorusing there. Let me turn up the chorus a little more and the density more. It's going to sound really intense now. Taking it down some, and now we'll run the sequencer. Now we'll switch over to delay, and these are the built-in values, not the tap values. I'm not going to be tapping today. And you can't see it, but there's a noticeable delay between when I trigger the note and when you first get the sound. I'm going to turn up time and density a little more. As you can see, it tails off very long. This is going to be a real long tail. I don't even know if this one's going to stop. See, that had no intention of ever stopping. So if we run that in a sequence, as you can see, it quickly saturated when both values were all the way up. Now we'll go ahead and do reverb. Okay, so this is dry. I have to adjust the gain. The reverb takes a bit of volume out, and now you hear a little 60 cycle hum. I don't know what's causing that. I'll figure that out someday. Now we'll run that. I just slowed the tempo down. That's with delay on. The delay is really good. Turn the tempo up. So as you can see, it works pretty well. Sounds good. Obviously, we haven't messed with adding time density through control voltage, and we haven't synced it because we can sync it to the sequencer, I think. I have to see whether I can pull that off and do lots of other things. So that's it. It's a good build. The hard part, which would be the daughter board DSP, is already surface mount soldered for you, so there's no big issues. Another good unit from Frequency Central. And thank you for watching.